Even so, the amount of data processed by the computing center is impressive. Initially, this data is stored on thousands of hard drives stored in computer racks. Scientists can therefore access the data they need for their research very quickly. Yet the amount of data is so large that it would take several decades to analyze them, even if CERN had a network of computers that could process millions of operations per second. Unlocking the secrets of matter in the universe takes time, a period of time that is much too long given the fragility of the hard drives on these servers. This is why the CERN IT engineers had to use another medium to ensure the long-term storage of their valuable data.
The Large Hadron Collider data are stored here. Here means in these cartridges that contain tapes. Automated units like these fetch them when a physicist needs to re-examine or reanalyze data.
There are more than 50,000 robot-managed tapes, which are used as archive media for all of the LHC data.
Why tapes? In fact, I've been here at least 15 or 20 years, and the same question always comes up. Aren't we going to change the system? The answer is no. There are several reasons. First, recent analysis demonstrate that tapes are 1,000 times more reliable than discs. Second, tapes, when they are not reused, don't consume any electricity. Third, if you drop a hard drive, there's a very good chance that it will be completely destroyed. That's not true of a tape. The plastic container could be damaged, but we would be able to retrieve the data.
Proof of its reliability, the first computers made in the 1950s opted for tape. And since this pioneering era, the storage capacity of tapes has been constantly increasing.
The storage capacity of tapes, as for disks, and the density of transistors on a processor is limited. Yet today, several manufacturers have proven, through lab tests, that tapes could achieve a capacity of 50 terabytes per cartridge. We are therefore at a factor of 10 from these theoretical limits.
The quantity of information generated by the LHC may seem to be enormous, but it is just a drop of water in the sea of data that we produce on a planetary scale. Over a 24-hour period, 145 billion emails are sent, some 4.5 internet searches. Every day we generate 2.5 trillion bytes of data. These astronomical numbers are so hard to conceive that the computer sector had to invent its own scale based on the byte. A byte consists of 8 bits, representing zeros or ones. Therefore, a single character of text corresponds to a byte. 1 page, 3 kilobytes. 300 pages, a megabyte. A library, a gigabyte. 5 libraries, a DVD. 6 million books, a terabyte, or a stack of 200 DVDs. A 200-meter stack of DVDs represents a petabyte. A 1-kilometer high stack of DVDs, in exabyte, is the equivalent of all the information produced by humanity through 2003. A stack of DVDs stretching from the Earth to the Moon represents 1.8 zettabytes, or all the information produced in the year 2011. A stack of DVD linking Mars to the Sun represents a yottabyte, or the volume of digital data generated within the next 5 years. At first sight, no existing medium could store such a huge mass of data. Does this mean our societies are facing an impasse? Certainly not. Scientists responsible for storing data have understood that we now have to change our mindset. They are now looking at a device we all carry within us and that has already proved to be effective. This complex system, whose immense resources still hold many surprises, is DNA, contained in the chromosomes of all forms of life. Nick Goldman and his team are exploring this aspect of DNA at the European Bioinformatics Institute in the UK.
There's lots of reasons why DNA is a good medium. It's very, very small. It's very inexpensive. It lasts a very long time. It doesn't require any energy, and we will always be able to read DNA. So something like a floppy disk is no longer readable. In a few years' time, probably DVDs will no longer be readable because we won't have the technology any longer to do that. But DNA, we will always have some technology to read DNA. The technology changes, and at the moment it's changing very fast. Every couple of years there's a new machine to read DNA. But because it's the stuff in our own genomes, we will always have a new machine that can read DNA.